Welcome to EtherLink AI Insights, the podcast where we dive deep into cutting-edge AI development. I'm Alex, and I'm thrilled to have Sam with us today. We're tackling something really exciting, Agentic AI development in 2026, and specifically how RAG, MCP, and multi-agent orchestration are reshaping what's possible in production systems.
Thanks, Alex. And honestly, this is a topic that doesn't get enough attention. Most people hear AI and they think ChatGPT, a really smart chatbot. But agentic systems, that's a completely different animal. We're talking about autonomous systems that can perceive, plan, execute actions, and adapt in real time.
Right, and the scale is staggering. I saw in the research that 65% of enterprise AI deployments now have agentic capabilities, up from just 23% a couple years ago. That's huge adoption. So what's actually changed between a traditional chatbot and one of these agentic systems?
The core difference is agency itself. A chatbot waits for you to ask a question, then gives you an answer. An agentic system? It perceives what's happening around it, sets its own goals, breaks those goals into multi-step plans, executes actions through tools and APIs, and then learns from the results. That feedback loop is fundamental.
That sounds complex, and I'm guessing error management is critical here. If an agent is autonomously executing actions, you can't just let it hallucinate or make mistakes without consequence.
Exactly. This is where extended thinking comes in. Models like Claude 3.5, Opus, and OpenAI o1 allocate extra compute at inference time, not training time, to do deeper reasoning before they commit to an action. We're seeing error rates drop by up to 68% when agents use this extended thinking before executing API calls or making decisions.
So it's like the agent is pausing to think through the problem more carefully before acting. That makes intuitive sense, but I'm curious about the architecture underneath. You mentioned three pillars: RAG, MCP, and multi-agent orchestration. Let's start with RAG. What does retrieval augmented generation actually do for agents?
RAG is the knowledge layer. Instead of relying on what was in the model's training data, which gets stale, RAG lets agents dynamically pull current information from databases, documents, APIs, whatever. But here's the nuance. Traditional RAG systems are one way. You ask, the system retrieves and answers.
And agentic RAG is different?
Completely. Agentic RAG is bidirectional. The agent retrieves information, acts on it, gets new data from that action, and feeds that back into the vector database. The agent's observations actually update the knowledge system in real time. It's not just consuming knowledge, it's contributing to it. That's a fundamental shift in how you architect these systems.
That's really clever. So the system is essentially learning and improving its own knowledge base as it operates. Now, MCP, Model Context Protocol. I'll admit this one's newer to me. What's the value there?
MCP is honestly one of the most underrated pieces of agentic architecture. It's a standardized way for AI models to connect to external tools, APIs, and data sources. Think of it as a contract, a consistent interface that lets any model, any agent, talk to any tool without needing custom integration code.
So if I'm building multiple agents, they can all use the same MCP servers?
Exactly. You write an MCP server once, and any agent, whether it's specialized for customer support or financial analysis, can use it. It drastically reduces development time and maintenance overhead. Organizations are seeing 40% faster time to production for custom AI agents when they use these standardized frameworks versus building everything from scratch.
That's a significant productivity gain. Now we get to multi-agent orchestration. I'm imagining you don't just have one agent doing everything. How do these systems coordinate?
You're thinking about this exactly right. The most effective pattern we're seeing in 2026 is hierarchical orchestration, what's called the AI-led architecture. There's a primary reasoning agent that acts as a coordinator. It delegates specialized tasks to sub-agents, each optimized for a specific domain or function.
Like a conductor directing different sections of an orchestra?
Perfect analogy. One agent might handle customer communication, another manages data retrieval, another does financial calculations. The lead agent coordinates between them, manages context, and ensures they're all working toward the same goal. And here's the kicker. This hierarchical approach reduces hallucination rates by 47% compared to flat multi-agent setups. You get better accuracy and cleaner reasoning.
So structure matters as much as the individual agents. That's interesting because it suggests there's an engineering discipline here, not just throwing compute at a problem.
Absolutely. And that's where a lot of teams stumble. They focus on making individual agents clever, but they neglect the orchestration layer, the communication protocols, the state management across multiple agents. That's where 35% of production complexity actually lives, according to recent analysis.
Wow, 35%. That's the vector database architecture piece, right? Managing all that context across multiple agents?
Yes. Multi-tenancy isolation, ensuring different agent instances have separate vector spaces, managing memory efficiently so agents don't get confused or step on each other's toes. These are solved problems now, but they require careful design. You can't just bolt on a vector database and hope for the best.
What does best practice look like? If I'm building a production agentic system in 2026, what am I actually implementing?
You're building with awareness of EU AI Act compliance. For one, governance and safety can't be an afterthought. You're implementing clear perception layers that integrate real-time data. You've got a planning engine that decomposes complex goals into executable steps. You have action execution with built-in tool calling and state management. And crucially, you've got evaluation frameworks measuring everything: accuracy, latency, cost, safety metrics.
That's a lot of moving pieces. But the payoff seems clear. You get systems that are faster, more accurate, and more autonomous than anything we had even 2 years ago.
The payoff is real, but let's be honest. It requires rethinking how organizations approach AI development. You can't treat this like you're just tuning a language model. You're architecting intelligent systems. It's software engineering at a new level of complexity.
And I imagine the evaluation frameworks are as important as the architecture itself. How do you even measure if an agentic system is working well?
You measure multiple things. Accuracy: does the agent complete its goal correctly? Efficiency: how many steps? How much compute? How much cost? Safety: are there any unexpected side effects? Robustness: how does it handle edge cases or incomplete information? And then you measure the second-order effects. Is the system actually learning over time, improving its own knowledge base through RAG, adapting its strategies?
That's sophisticated. It sounds like success in agentic AI isn't just about having a smart model. It's about building a system that's intelligent at every layer.
That's exactly it. And that's also why the 2026 landscape is so much more mature than 2024. We've learned what works and what doesn't. We've got patterns, frameworks, and best practices. It's not experimental anymore. It's engineering.
This has been incredibly clarifying, Sam. For listeners who want to go deeper into the technical architecture, the evaluation frameworks, and specific implementation patterns, the full article, Agentic AI Development 2026, RAG, MCP, and Multi-Agent Orchestration, is available on etherlink.ai. There's a lot more detail there about vector database optimization, MCP server design, and how to actually orchestrate agents in production.
And honestly, if you're building any kind of intelligent system, whether it's for customer support, data analysis, or automation, this stuff is essential knowledge right now. The field is moving fast, and understanding these foundations will put you way ahead.
Thanks for breaking this down, Sam. And thanks to our listeners for joining us on EtherLink AI Insights. We'll be back next time with more deep dives into the AI systems shaping the future. Until then, keep learning.